Hi friends, so we are into fourth lecture of human factor model as part of risk conscious operation management of complex engineering system. Slowly we are approaching towards development of the model, and for any model to be developed, we have to have first a reference model. So this lecture will focus on creating a reference human model, because from there on what are the deviation, how stress plays a role, we can work out. And then the best part of human reference model is we are able to have a top down approach for root cause analysis. If some event has happened or some deviation has happened, then what could be the fundamental root causes that can lead to those kind of events. So one is that human model is reference human model is available for quantification. Second thing is, in a qualitative state itself, there is a lineup down lineup to investigate the root causes of. Of course, this model is continuously evolving, so it is not exhaustive, but then yes, I would say 70% or 80% we have touched upon realization of link between what happened and why happened, which used to remain somewhere in vague domain, and root cause analysis for human failures we were not able to do because reference model was not available. Okay, so the analogy is from the hardware, the way we have draw a fault tree to understand a system failure. The question is whether we can extend the same philosophy or analogy to human modeling also, and yes, we can do it. We can do it so that a reference model is available for us to work on the root cause analysis. Then the question comes is how to do about the quantification. So quantification also, as we will see in the next lecture, we can do certain time to a great extent using some expert opinion approach. Okay, and that's why, and we can go on consolidating the this human reference model as and when more data and information that is available. And then now we will talk about the axioms and element of human modeling. So human reference fault tree, I am using a fault tree approach to create this human reference model. And of course, finally I will conclude this talk with some comments. The critical requirement for reference model training and qualification, because if I consider a human which is qualifying the criteria for a human conference, so what should be the reference conditions? So like I buy only quality item in the plant to expect some reliability growth in the plant or reliability assessment in the plant. So at time t is equal to 0, we have the quality levels. Okay, that's how it has been included in the plant. So how to ensure a quality for a reference candidate or reference human? So first is educational criteria. The educational criteria should be he is an engineering graduate and with a good percentage mark and excellent conduct certificate. So these things they are sufficient as an initial condition to qualify him as a reference candidate. Second thing is holistic training in domain area. The candidate goes at two levels of training, at the organization level and at the plant level. So how he is gone under, what are the infrastructure that is, what is his quality level, and one of the way to determine that is what are the infrastructure available, what are the organization level support that is available to the candidate for getting an excellent training actually, and then what grade he obtains in the training to come further near to a reference model. Then some input also comes from other than the training department, how he is performing in the real time plant areas. Okay, so some sort of, and then he is grading performance by the experts and all. So this I have shown here is third stage. So it further consolidates him as a reference candidate for consideration as a human reference model. Now, if we go ahead, we'll see there are many examinations are performed regarding his well-being, his physiological, his stimuli, how this eyesight, his other criteria, whether he has any physical or physiological issues, well-being related issues, intelligent quotients. Certain organization they try to, but this job is done better by interviews and a grading system. So that is at one stage, and then finally when he gets through, then what is the grade that he gets, like A plus and all that. He is the one of the ideal reference person for conducting. What we are trying to say is, whatever existing procedures are there, how far they are able to complying to the development of a human reference model. Okay, then his actual service will determine whether what was the training feedback for this one. So now once the candidate is authorized, that means the organization has qualified him for a certain job, and now he can be authorized to do or take up the particular job. It could be a shift engineer, it could be a technician, it could be a maintenance person. So qualified. So then we call the person is qualified to do this job, and his real-time behavior or performance will determine the way hardware component, when they are used in the plant, and their failures or operation and the kind of maintenance that is required, we characterize them in their performance. That is basically to characterize the reliability and quality. Similar situation happens here also. Okay, and then now reference physical and physiological, cognitive, psychological requirements. I mean, what are the requirements? This is what we talked about, a system that we develop. But then what are the basic attributes that are required? The basic premise of the CQB model reliability is creating is human model, right from individual brain function, sense basis, capabilities, cognition, consciousness, memory, modeling of the complex brain cognitive modeling based on available state of the art in objective to reduce the uncertainty in human performance prediction. When we are certifying some person, if we have these qualities, it becomes easier to expect the role. The organs are, let's say if we talk about internal organs, external sense basis, it is not external organs, a sense basis which interact with the outside world, So that is one, and body organ enable tasks to be performed physically and mentally as part of the job requirement. Physical fitness, okay. So physical fitness, mental fitness, cognitive, intelligence, all these things they form directly or indirectly some criteria. 6 sense bases are there, like we have discussed this earlier. So they also become like a vision, listening, nose, tongue, skin, mind, they become 6 sense bases. The action organs are mouth, speech, legs and hands. Okay, so these are the things, and I think even the routine or existing reliability, human reliability methodology, they have this kind of considerations, and okay, and then the medical examination at the entry level, at the same time as a follow-up periodically, annually, or maybe once in 2 years, whatever the organization takes a decision, that will tell us the physical fitness and mental fitness of the person. It might include a psychological examination if required. Additional parameters, a system of ensuring working of cognitive and ethical moral behavior. These are also slowly becoming metrics for checking performance of a expected performance of a system or human. Now, if I have to create a reference model of the plant, as you are all having these classes. So you know fault tree, event tree and all that reliability approaches. There is a top event, logical gate, and then one more intermediate event occurs. Then the tree goes on expanding on both the sides, and we have again logical gate, more intermediate event, logical gate, and finally we come to the basic event. Either you come to the basic event or you come to a event which cannot be developed further, because knowledge is not perfect in all the areas. So these events are left to have further R&D for further data or expansion of that particular node of the tree. Okay. So this is the broad how we see that as a requirement for human model development. And I think this is in line with hardware systems. We develop the system, plant system, and component reliability model. Okay. The objective of creating the reference human model is to evaluate human error probability data for routine. For our ultimate objective is what is the probability that the staff will do an error. Okay. And every error will not lead to accident. Let us keep it in mind, because for accident a couple of event has to happen, then only accident happens in any plant, because there is a huge provision of redundancy, diversity and all that. But of course, there is one element which is called common cause element, and in the context of this particular topic, it is the human common cause failure. That kind of thing can be avoided. So the impetus comes from there actually in respect of the human modeling actually, or human factor modeling. The approach is top down, we know that, and the fault tree suits it very well. Probably in the future model we will create an event tree also. What are the checks where human factor comes at the event tree top, that is a header event, and then how fault tree can provide those kind of inputs. Then various layers are starting from top to connected to the logical end. Finally, we go to for representation of the fault tree is essentially a qualitative model. It is a quantitative model, but a first stage of qualitative model itself does a great harm if we want to do any precursor analysis, if we want to understand any root cause analysis. So we will be remaining at the level of qualitative fault tree in this CQB model, but certain examples will give at the node level, which you will understand. If you do for all the nodes, it becomes a quantitative model also. The challenge here is to get an individual event data. The expert opinion approach in fuzzy logic, there is a question of lack of data, especially in human factor modeling, but then there are advanced knowledge base, that is fuzzy logic. Fuzzy logic is just, if you see the context of normal logic where 0 and 1 happening, not happening, but fuzzy logic has got a continuous spectrum of 0 to 1. So if somebody is intelligent, average, highly intelligent, most intelligent, you can have those kind of qualification, and that really works for the real time situation also. It is not possible somebody is intelligent or somebody is not intelligent, which is the norms in crisp logic. So fuzzy logic suits. I will just touch upon this last part, and then we will go to the next part. And then let us say we have come to our reference human. So you can see here human model reference we are creating here. The objective is to create the reference human model. Now, like fault tree, what constitutes human model? Material. Okay, and then the spirit. So spirit, matter, and you can say non-matter. Consciousness and conscience, they are non-matter. At least for this, our postulation for CQB is like this. Matter can have a physical body and mind consciousness. We do not know as on today mind is matter or it is non-matter. So mind consciousness, we talk about it. So that's why I taken matter. And then physical body, internal and external. External stimuli, sense bases are there, and then internal are intellect, nervous system, central nervous system, and all we have taken over here, and then emotional intelligence. Okay. So even though I have taken emotional intelligence over here, it need not be a matter, it could be a question of attitude. So there is very thin line between, like we have a wave particle theory. Here also we have a matter and non-matter theory. But then since we had to have a taxonomy here, we have put it here, and then like that this fault tree has been developed, and further nodes which have been developed here, it has been given a number. Okay, they are called transfer gates. So like you have a fault tree OR gate, that means human model, failure will occur. Here we are looking for failure when we create a human model. So either matter failure or spirit failure. Either it is a physical symptom of the body, or it is a consciousness and conscience and all that. Consciousness, physical manifestation. So again we have attached here. As I said, there is not a very well defined line. Implicit components, life force, sources, intuition, and conscience is moral, attitude, ethics. So conscience, you can see it has reached the basic event. So probably further development may not be required from this node at least. So we have reached the basic event. But other events like intellect, we have gone further 2, 3 and all. So as we proceed, I was focusing on the sense basis because that is the best example to explain. So I have gone to the next stage. So you can see intellect, there we had come, and our central nervous system is the brain and spinal cord. Okay, and then we have sensory communications, peripheral nervous system, intelligence. All a lot of medical terms we are using, but finally we are in the realm of defining a human. So medical terms cannot be avoided. Okay, so the spinal cord. Now spinal cord you will see in the fault tree 9 which has been developed. Similarly, frontal lobe here, and then occipital lobe. As I told you, I will take the example of occipital lobe or eyes as a sense organ. So we have occipital lobe here, that is for 13 has come here. So same way other nodes also have been developed, but just it's a very expanse is very high of this fault tree. So I am trying to make a rational to explain it how we go on developing the things. So the left vision cortex, right vision cortex. What we are talking about, at some point on occipital lobe we talked about, sometimes we talk about the organ. So that means for vision, the function of occipital lobe is also very important. That is a brain, role of brain, and role of eyes, left eyes and right eyes. That is also very important. So here left visual cortex, right visual cortex, and then positive, then long-term memory, executive involvement of recognition, short-term memory. There are so many memories are there, and what happens is ventral region. I think it has come halfway. Ventral and dorsal region. So what you see how beautifully we have explained activities happening at the brain level. At the same time, we are taking individual vision things also. We have connected to it to the conscious seeing also, and it is a complete model. Now it's we are in the realm of only qualitative development of this model. Now if you see further, we have developed the sense basis here, and we have developed eyes. Okay, in that cornea, lens, iris, retina, all these things also we have developed. So these and the activities happening at the level of the brain represented as a part of the human model. I think it's a big explanation to if we want to root the root cause at the level of stimuli, seeing, watching, okay, and any mistakes which is happening there, what could be the basic element. So these are all basic elements. That means here the left eyes things start, because these are constituting component or basic events of left eye. Similar thing will be right eye also. Don't have to create a new node. So same thing will go and plug here. So in fault tree analysis, the software, the provision, application software provides a provision. This node can be clubbed here also. So it will have a different meaning and with the same thing also. You don't have to rework again and again. Okay. So here we are now. Now what is going on at the level of the brain we have seen in previous slide, but in terms of memory, because with every stimuli, we have memory is coming up. So, there we have human memory, and on broad basis it is sensory memory, short term memory and long term memory. I saw something and that is it. It has gone into my, how long it will remain, and long term memory, I am operating the plant. So, I should have a explicit memory and implicit memory, procedural knowledge which is there and declarative knowledge. So, both should be there, and then explicit memory is episodic memory, that means related to one time event or rare events, and semantic memories about structure, system, information about the plant, procedure, methods, what all required to perform it reliably and with minimal risk. So, these memories function we have got here. So, processing, sensory processing is there, and there can be a component of common cause failure. Common cause failure means where everything gets wiped out. Some people go to this stage when they are not able to recollect anything. So, that is some common cause area is there which is affecting sensory memory as well as long term and short term memory. So, this is called common cause failure. So, and then the storage, long term working storage. So, which are the organs? So, hippocampus is a synapse and neurotransmitter, and finally chemical and electrical processes are involved. Because we have not gone, there could be a science of chemical process, there could be a science of electrical, but since knowledge, as far as knowledge is there or expanse of the tree is there, we have stopped here. This will not remain basic event, they will be developed further on this once the knowledge base that is available. But now we are pretty sure that we have to go beyond this, and this will be a future research actually. Now, so now we have coding, retrieval efficiency, all those things they matter a lot. And at the level of the brain, how it, so perceptive memory, attention memory, conceptual memory, and episodic memory, and then associative memory, relating something to other. So, these things they happen, and we have identified the area of the brain. If there is a problem, there is something lacking. Okay. If something happens that balance, some people they fall in the area and all, cerebellum, is it the cerebellum or it is the local issues, is it physiological issue, it is some disease which can be related to any of the, so we can connect it to the various roots. So, human reference model development limitation, I mean there are many limitations because we are developing a complex system, human is a complex system. It becomes particularly more challenging when the human model is created with its basic constituents, organs and faculties. Because a lot of healthcare science is also required over here. Further certain aspect like consciousness, I mean there is no agreement on consciousness, but one thing I think I would like to say that for the development of CQB model for human reliability, we have acceptable assumptions, acceptable postulates, and acceptable paradigm or boundaries that we can define, we are able to define or connect consciousness to the real time scenario or problem that we are handling. The spirit, their resources and understanding, of course. Though there is no claim in this work at the fall tree down exhaustive, it is not exhaustive as I mentioned, because further notes to be developed, okay, but it has provided a canvas for to go ahead. Okay. The objective here is to reduce uncertainty. So, even if we reduce 10% uncertainty in human performance prediction, I think a big achievement actually, and that is how we are converging to many areas. Here human reference model is being developed by considering the available stuff, and one achievement is we are able to go ahead and surpass the present reliability methods. So, and then if we do the quantification, probably it will be a tall order. In view of there is many transfer events that carries. So, wherever we have accepted, yes, we agree, but there are some basic events also we have to work on it, and I think for that research and development, but research and development go hand in hand. What is the real time requirements we might feel sufficient with the existing CQB model also, because we are able to do root cause analysis, we are able to do precursor analysis, and we are having a model where even it can provide the plant people if something is happening with some person repeatedly, what is the problem. That kind of canvas is available. So we have seen the qualification criteria. What is the reference qualification criteria for humans to be called candidate consideration for reference model? A fault tree approach has been used. The fault tree was very long. Actually, you can refer my book, this chapter 7, the complete fault tree is available, or probably I might share with you this chapter. I'm not sure the copyright issue and all that, but it is there, part of my book on risk conscious operation management. Modeling human is a complex task, and it is so these are the real time challenges, and we are trying to address one by one the approach reference model. And next is we will be discussing the quantification, and there probably you will see what are the real time issues. At the same time, because human reliability is is a quantified thing, so we in certain areas we will go back to our original methods and make it feasible. So model will be available, modern knowledge plus existing knowledge, and it will take it one inch ahead in giving the state of the art in human reliability modeling.